Hi everyone, thanks for attending this presentation. So I'm going to talk a bit about some of the work we've been doing at Clyso. It's focused on a build system for our enterprise storage product, but it is somewhat generic enough to allow for anyone who wants to build container images for their own benefit to just use it. And I will walk through some of these things during this presentation. First of all, I'm Joao. Hello. I've been with the Ceph project for a little over a decade. I've went through multiple companies. Nowadays I'm at Clyso, where I'm leading the development of the Clyso enterprise storage product. And this is basically how we end up here. So what is CBS itself? Well, the idea is to have something that allows us to build and put together releases as easily and as automatically as possible. So CBS itself is a collection of tools that allows us to achieve this exact purpose. Oh, I'm sorry, I should mention before then, it's like this is available on GitHub. Feel free to just, look at it. A few disclaimers before we continue. Let's keep in mind that most of this was informed mostly by a lot of manual work that I had to do and didn't want to do anymore. The idea is to ensure that the buzz factor that we have in the company in terms of releases is increased from just one. What? Oh yeah, sorry, I just completely spaced out. And this was, it has been developed according to our evolving needs. This continues in the sense that because it has been developed according to matching needs, it was not initially properly designed. It grew organically. So there has been a lot of refactoring associated with this, and which leads us to it not being as declarative as I initially wanted it to be. But it's still getting there, gradually and slowly. But if you go through the GitHub repository, you will also see that it's still a bit tied to some of Clyso's internal infrastructure, like how we have our vault and all of those things. Although all of that is configurable, it still relies on having a HashiCorp vault, an S3 service, and although these things can be changed as we go, and depending on interest associated with the project from other parties. The guiding principles on this project have and will continue to be the containerization of the entire workflow. Everything is built within the context of a container, so we have always a clean slate, and it always ends up resulting in a container. We always end up building a container. It's declarative as much as possible in not only what we define in terms of what is to be built, but also how it is to be built, and in the end, where things are to be stored. And it's flexible in the sense that it can technically build anything. We use it to build Ceph and other goodies that we may want to have on our images, but it can technically build anything as long as you can describe it. So in terms of what we intend with this, essentially we want to create custom versions of Ceph. We have whatever is the base version of Ceph, may it be upstream or whatever, and we may want to apply backports or tunables or whatever and ship this to someone. On top of that, we may want images that are not just based on Ceph. It may be Ceph plus other goodies, like tools or whatever. We want to make sure that every single artifact is stored somewhere, not only the container images, but potentially any transient artifacts like RPMs, because they can be used for other purposes, not just container images. And personally, and this is my own bit, I want release notes to be automatically generated as possible. I don't want to keep patch sets of them in spreadsheets. It's just, I just want something that I can press a button and will create me a very consistent markdown document. So, most of these things are initially achieved by what we called a release tool, because I'm very good at naming things. The initial idea of having this release tool is to reduce as much all the manual work that goes into building a branch of Ceph plus any number of patch sets. I personally like this to be as automated as possible, control the entire release lifecycle from the initial branch all the way to the final release through all the potential iterations of release candidates. I wanted this to be potentially a collaborative effort. So these releases are mostly metadata. Basically, a release is described by a bunch of metadata that includes patch sets and can be collaboratively worked on by multiple people up until the moment we decide to publish a given branch. Once that branch is published, it means that it is put together and pushed to a Git repository somewhere to be built. To have a brief idea of what this looks like, in this case, this is basically creating or an initial release. We're basically specifying that we want a release, let me see if based on Reef. What this is basically doing is creating a branch somewhere that is based off of that version of Reef. Then we start by creating iterations. An iteration can be an RC, can be whatever you want. It's something of a version that is contained within this release cycle. To this, we can add patch sets. May they be custom local patch sets or directly from a GitHub pull request. In this case, it's just pulling all the patches from a given pull request, applying them onto a branch, validating that they apply cleanly, and if they apply cleanly, then we have successfully added this to this iteration within this release. We can see that, okay, so at this point, if we are comfortable with just releasing this iteration, we can just say, okay, just finish this iteration, push it somewhere, and in this case, it is pushing it to here, which I believe is the branch. By the way, all of this is crap that is lingering still, but it will go away at some point. But this branch is now ready to be tested and, well, built first and then tested. To have an idea, this is what it looks like in terms of metadata. This is whatever the release is defined as. These are the patch sets that go into that release. Once we're done with the actual iterations and we believe the release is finalized, we can just finish the release and it will push the final branch to Git. Believe it or not, this simplifies working on a release with dozens of patch sets significantly, because you don't have to keep remembering where things are and which things went into the actual release. We can actually remove patch sets between iterations. If things don't work out, you can just remove a patch set, add another, and continue with the release cycle. And in the end, it's this metadata that is kept that will allow us to generate release notes, which is, honestly, in my opinion, amazing. But then comes the part that we actually have to build this stuff. And for this, we have, within the build system, this bit called, again, naming. I'm very good at that, CBS core and CBS build. CBS build being the tool, local tool, that will be building these things. So this tool essentially requires us to first define a version. This version means that we define where we get the code from and where the container will end up being. Then it will locally set up the local environment. That means scratch directories for transient artifacts. It will mean also Ccache, which I highly advise if you're building Ceph, and whatever else it might need, which I added there, but I can't read it, and I have no idea what it was. I'm sorry. But regardless, moving on. So the build system itself, or in this case, the build tool, will first start by obtaining the branches from the various components. I will get there in a bit. The various bits of the release that are going into the final image. It will obtain those repositories, and then it will build them. These will be built within a container. RPMs will result, which are signed and pushed to S3, and then consumed by the next step to build the actual container image. Things are consumed from S3, and the container image is built, pushed to a registry, properly signed, and all of those things that are neat. But I did mention this bit here, components. Components is, again, naming. Whatever can be built. If it can be built, if you can define it and define how it can be built, I call it a component. Ceph is a component. Clyso tools may be a component. A manager module that we want to throw into the system is a component. Whatever we can define and build RPMs for is a component. That's basically it. What we have here is a declaration of a component. It's called Ceph. It's consumed from this place. These are the bits that we actually need to build the component, like in this case, stuff for RPMs, and here, for instance, to install the dependencies for the build. And then we have this bit here, containers. This is the location of the container descriptor that will allow us to actually build the final container. These container descriptors are nothing but a glorified Docker file. The only difference is that it's split into sections, and each section will be handled at different phases of the build process for all the involved components. So if we have multiple components with a config section, all these configs will be applied to the container image for all components at the same stage of build. Not just the config, we have a pre-section that defines the various repositories, packages that need to be built, that need to be installed previously to all the other packages that may be needed for instance, running scripts. And these things are all, for all the components, these things will be run at the same time, again, in a specific phase. Not just the pre-section, we also have packages that will be installed on the image, and the post section. Again, if you look at this and you look at the Docker file in the Ceph repository, it will almost map one-to-one. The only difference is if we have multiple components, the various sections that we apply from the various components will be applied in phases, instead of just one Docker file that is run through from beginning to end. Using this, just to give you a bit of a taste for it, is just like, run this tool, create the version that I was saying that we need. This is a descriptor that basically defines what is going to be built, where it is going to end up. No, actually, what is going to be built and where it's going to end up. Then we just say, okay, build me this thing, and it will just run through building, installing packages. In this case, we actually are not building anything because the RPMs for this particular version were already built. So we'll just consume these RPMs from S3 and skip that build. This is useful if you actually are, if you actually have multiple components and you only want to update one of them. You may not want to update Ceph if you just want to update a tool within that container image. So you just consume Ceph from the build system instead of having to compile it again, which takes a little bit. If you have ever compiled Ceph, you will notice that. In this case, we're just, in the end, just updating, pushing the container image to the registry. So this is all interesting for me. Well, I find it very interesting. But building stuff locally is kind of annoying because you are basically limited by your local machine constraints. Not everyone gets a beefy machine to build these things at home. And on top of that, there's this thing that is really we should consider in terms of secret isolation. If I'm building stuff on my own workstation, what happens is that I'm grabbing secrets from our corporate vault to sign RPMs. And even if it's just for a little bit, they are living in my workstation. Personally, I would rather have this as a build service and have multiple people being able to build on their own without actually having to ever see one of those secrets. So hence the concept of having a build service, which looks a bit like this. Here we have basically the CBS core bits. It's the bits that are going to be building the whole thing. But here we have the equivalent of a REST server with a work queue that is just pushing builds to a worker node. These builds can come from anywhere. It's just, again, a REST server. And it adds versions to a work queue and then pushes that to a worker node. It's a very basic approach. So basic that we can just spin off multiple worker nodes and have multiple builds in parallel. The concept is not new, it's just a work queue that is scheduling work. We have a Podman compose file on the repository that will set up something very basic, and you will be able to just schedule builds locally in your machine if you want to play with it. But to actually enable this for folks, we implemented a command line tool called CBC, again, naming, CBS client. The CBS client basically allows you to do the same thing you did with the CBS build tool, but the only difference is that it will push stuff to a central server. However, we ensure that you need to log in somehow so that we have basically an SSO support for Google in this case. If you want to actually use the CBS service, you actually have to log in with, in our case, with our Clyso accounts, and then you can schedule builds. And that means, just say, again, I want to build Ceph at this version and push it. It will schedule something, state pending over there. If we can do multiple builds, and as long as we actually have worker nodes to work on them, they will be scheduled accordingly. This means that if we list it, we get one that has started, one that is pending, one that was a success, one that was a failure because I actually had a bug at this point. There was an annoying bug, so I actually had to reschedule these things. And yeah, this started, the other one is pending, it succeeds, the other one starts, and it succeeds because we no longer have bugs. It's a perfect product right now. And yeah, okay, so, believe it or not, yeah, I'm through this whole thing. In terms of future work, basically what I would love to do is to actually have automated testing between all these steps, especially the build stuff. So we go from an actual putting together a release, having it build automatically, testing it automatically, and go back to the release phase if we need to. And ideally, we would have, this is honestly what I would like to work next on, having something that integrates it all with a nice user interface, with a nice workflow and things like that. This is also something that I believe to be very important, because at some point we may want to allow people to build their own dev branches, but not build final releases. We want people to actually build their container images, but not push a new product version out. That could be problematic. And in the end, I really just want to have proper chain of trust in terms of the repositories, and potentially even SBOMs being generated automatically without actually having to do manual work. That's it. If you want to look at the project, again, it's here. It's on GitHub, and thanks for coming and listening to me. That's it. Hi. Any questions? Okay. Great. Thanks. Very much appreciated. Yeah, we have Zach.
Yeah, one question for you about your build service.
Yeah.
Is this scheduling and orchestration something that you implemented as like a custom solution, or are you using some other tooling?
I'm using Celery, basically, from Python. It's a work queue thingy. And it uses Redis as a broker. You point it to Redis, you point it to, yeah, and it figures it out itself. And I would not be implementing that kind of stuff. That seems redundant. But yeah, in this case, it's just a broker with a work queue. Yeah.
Yeah, well, I think I can speak from here. I have a question about the backports. But I think I can speak louder, but you also automate the process of conflict solving in the backports, or how do you deal with that?
No.
There are no conflicts.
No, there's never conflicts.
Oh.
Of course not.
Okay.
It's all magic. No, on a serious note, if there are conflicts, you have to look into it manually.
Okay.
What we do, and it's not shown here, is that we have the concept of a custom patch set. And here I just showed stuff that is pulled from GitHub. Generally speaking, we're talking about, from a product point of view, we're talking about having a specific Ceph release that needs backports that haven't been released yet, but have been properly backported. So it's like most likely, those are more likely to apply cleanly than a patch that you pull in from main, right? And as such, that kind of patch sets usually apply cleanly on the branch that you are working on. But if by any reason, may it be because you have multiple multiple patch sets on which that is dependent, or there's something that you have applied that is conflicting with something, you can technically create a custom patch set. Custom patch set is nothing more than telling the tool that you want to create a patch set based on a few commits that you have locally on your Git repository. And it will basically extract those commits, create essentially the equivalent, literal equivalent of the mail format patch sets that you would usually send to mailing lists and whatnot. It just keeps that there. It's a custom patch set that you can just apply later on. The release tool has a little bit more things than what is shown here. It can actually manage patch sets that you can apply on across releases, across iterations. It's but
on the patch sets, do you have any type of toolings for tracking like related set changes, change sets, right? Like this patch involves this previous patch, or you have to manually cherry pick all the.
Yeah, kinda. So it's right now it allows us. Did I merge? But anyway, the idea was actually to do that, to have metadata that allows to define that this patch set depends on that other patch set. But it is manual work. You can add that as comments or something like that.
Okay.
But right now it's manual work. I tried that kind of resolution at some point to implement that automatically, but it's a pain in the ass. Because you never fully know on what things something is dependent on up until the moment you actually try to apply something and you have a conflict. And then it's, in my experience, it's like a best effort in trying to figure out which patches actually touch that line. I wish I actually had all of that in a nice little package with a bow. It would make my life so much easier.
Thank you.
Yeah.
Yeah, somehow related question about the distribution you are building for. I had necessity to compile Ceph because it appears that Ceph is built for the stream version of the not RHEL, but
CentOS?
CentOS, yeah. But most of the companies, they afraid running this stream stuff. They want something stable with releases. They migrate to Rocky or something like this. Why did you choose streaming?
It's not stream. It's Rocky. We build everything on Rocky.
But I think I had problems with 18.2.2 and 18.4 already was not available for Rocky 8.
No, I'm not talking about upstream container images. These container images are container images that we have been building internally for Clyso. And all of them have always been based on Rocky.
Okay.
So basically what we do is simply, we don't care much about what is the EL base image. What we do is you specify an image and the EL version you want to build for, and it will build RPMs for that OS version. And it will use the image that you specify for the builds and as the final container image. I mean, you specify Rocky, and it will pull in a Rocky image. It will build everything within that Rocky image. It will push out patches, for instance, for EL9. Then it will bring up a new Rocky image on which it will install all the RPMs. That's what we do.
Okay, thanks.
But you can use CentOS, or you can use Alma, or Alma works as well. We've initially did this with Alma as well, and it worked. So it should work. I haven't tried it in a long time. It should work, though. Yeah. Are we okay? Are we done? Yeah? Okay, thanks. That's about it. Much appreciated.